Hi, my name is HaoZhu. I'm presenting my retrospective paper titled with Benchmarking Object-Centric Manipulation Using a Simulated Environment. The origin paper is Sapien, a simulated part-based interactive environment, which is published at CVPR 2020 as an oral presentation. Simulators allow quantitative and reproducible experiments, which enable the comparison of different algorithms on the same robot, environment, and task. It's easy to replicate and benchmark an algorithm, as data is more convenient to generate and collect in the simulator. The experiment environment is easy to set up, and the code can be released to the community, so new researchers can get involved in this area without buying expensive hardware first. Simulator can help researchers estimate the distribution in algorithm performance and investigate the robustness of algorithm performance due to environmental factors. And in most cases, training and testing robots in a simulated environment is faster than in the real environment. There's also a problem. Simulators are not a faithful representation of reality. Whatever is learned in a simulator can typically not applied in the real world. To make sure whatever the agent learned in the simulator can be transferred to the real world relatively easily, we need accurate physical simulation, robotics integration, realistic rendering, and content for simulations. Here are three key components of Sapien. The engine is built on the physics with pure Python interface and ROS integration. We expose articulation interface for robotics and word interface for access everything in the simulated world. The renderer supports many kinds of output like RGB images, depth maps, normal maps, and part segmentation through GLSL shaders, and it provides retraced rendering with the optics framework. With the environment, we still need objects for robots to interact with, so we provide the part mobility dataset, which is the first adaptation of the ShapeNet and PartNet datasets to include more than 2K models and 14K mobile parts. What can Sapiens do? There's a short demonstration video of a series of actions. First, the robot opens the door of a refrigerator and fetches the bottle. It places the bottle on table. Now, I will discuss some opportunities for improvements and new perspectives and future work since publication. For datasets, segmentation-related problems are easy to make since it is super frustrating to deal with more than hundreds of faces. Unfortunately, we have checked many times to make sure the models we released are free from this problem. And we still need more models in each category, although the total number of objects in the dataset is large. But for each category, there are only 100 models. Compared to some widely used datasets in computer vision, we might need more data to support training and testing. And Sapien supports prismatic joint and revolve joint. For screw joint, we have to adopt a hard-coded way. Other types are not supported yet. So in the future, once we optimize the pipeline of building dataset from 3D models, the system will be easy to use and available to the public. And more accurate models with fine-grained annotations are needed to enlarge the dataset. And we will add more physical properties in dataset. Given the dataset of articulated objects, the protocols, and the benchmark that define the experimental procedure and quantification methods are equally important. In the latest version, we present the benchmarks of vision algorithm for part detection and joint type recognition. We also show some interaction tasks that Sapien supports by demonstrating heuristic approaches and RL algorithm. These existing tasks are not really suitable for the environment. Obviously, More robotic perception and interaction tasks with the protocol and benchmark are needed to define. The simulator is simplification of the real world. Some details have to be simplified or eliminated, where the reality gaps came from. For example, we have found the friction sometimes causes anomalies in the simulator, so how to bridge the reality gap. This topic still needs a long time for us to explore. In conclusion, Sapien is a ready-to-use simulated environment for object-centric manipulation tasks, which can serve for both robotics and computer vision communities. We are still working on it to make it better, and we hope more researchers get involved to explore more possibilities. Thanks for watching.